Hello and welcome. This is Juma. So we are doing almost the last part. This will be our second last lesson, probably on metals. So we have done extraction of the metals. So we have looked at extraction of sodium, extraction of aluminium, extraction of iron, zinc, lead, and copper. Now we want to discuss properties of those metals that we have looked at during the extraction process. And we will start with the physical properties. So our lesson number 7, we are going to look at properties of metals, some metals. So physical properties. So these are the properties that we are going to consider as exhibited by metals: the melting and boiling point, density, thermal conductivity, electrical conductivity, malleability, and ductility. So let's just discuss them in brief, following the summary that I have. Let me just project it on your screen so that we discuss along. For those who wish to make the notes, at least you can have something to write down. So here is a brief summary of the physical properties of metals. So we have the sodium, aluminium, zinc, iron, copper. In terms of melting and boiling point, as you can see, starting from sodium going downwards, and those metals are in the order of reactivity series. You can see there is an increase from sodium to aluminium to zinc to iron to copper. And this is attributed due to the increase, the decrease in atomic sizes. The smaller the atomic radius, the larger, the higher the melting and the boiling point. And then in terms of just the value itself, even looking at sodium itself, metals generally have high melting and boiling points. And the reason is because metallic bonds are very strong. So to melt or to boil, it involves breaking those forces of attraction. In this case, we are talking about metallic forces of attraction, which are very strong. As a result, a lot of heat energy is required to break the metallic bonds, hence the high melting and boiling points of metals. The next property is density. Metals have a very high density. Now here, except for sodium, which has density less than water, because the density of water is 1 gram per centimeter cubic, but sodium has less than 1 gram, that is 0.97 gram per centimeter cubic density. So that's why sodium floats on water, because its density is less than that of water. But these other metals, when you place them in water, they sink because they have high density. They have very high density, and the high density is attributed due to their giant metallic structure, in which the atoms are packed closely together, in which this results to higher mass. Since density is directly proportional to mass, so the more atoms packed together result into higher density. So that is just because of the packaging of atoms in the metallic lattice and the sizes of the atoms. And then in terms of thermal conductivity, metals are very good conductors of heat as well as electricity. And this is because of the presence of delocalized electrons within their structure. The differences in the electrical conductivity in metals is because of the differences in the number of delocalized electrons. Generally, metals that have more delocalized electrons are better conductors than those which do not, that have fewer delocalized electrons. For example, group 2 elements have 2 electrons in the outermost energy level, while group 1 have 1 electron in the energy level. So that is the outermost energy level. So group 2 are better conductors of electricity than group 1 elements because they have more delocalized electrons, 2 against 1. While group 3 elements have 3 delocalized electrons in their outermost energy level. As a result, group 3 elements are better electrical and thermal conductors than group 2 and group 1 because they have more delocalized electrons in their metallic, in their outermost energy level. So the other property is ductility and malleability. So metals are ductile and this is because of or due to the slipping of layers of atoms over each other. Ductility is the ability of a material to be stretched into a wire. So that's why you usually have wires. They are made of metal because of that property. They can be stretched into wires. Metals are also malleable. So, and they are malleable again due to the presence of atoms in the structure of the metal. And for the same reason why they are ductile, it is also the same reason why they are malleable. Apart from being stretched into wires, they can also spread into sheets. That's why you have like iron sheets, metal sheets. You can see even we have an aluminium foil spread into a sheet. That is a property exhibited by metals because of the ability of the atoms to slide over each other. Hence they can be stretched into wires, that is ductility, and they can also spread or pressed into sheets, that is malleability. So those will be the physical properties of metals. So let's look at the chemical properties of metals. So chemical properties of metals. So these are the properties that we are going to discuss. Reaction of metals with air, reactions of metals with water and steam, reaction of metals with dilute acids, reaction of metals with chlorine, and reaction of metals with concentrated acids. And here we look at sulfuric acid, also known as sulfuric 6 acid, and nitric acid, otherwise known as nitric 5 acid. So starting with reaction of metals with air, generally metals react with oxygen to form metal oxide. For example, aluminium reacts with atmospheric oxygen to form aluminium oxide. And this is usually the reason why aluminium does not react with most of other substances like especially water, because of this coating. Aluminium oxide coating prevents further reaction. So this layer usually acts as a protective layer. You can be asked to give a reason why, apart from just thermal and electrical conductivity, why aluminium, being a reactive metal, is used to make cooking pots. The reason is because of this. Aluminium readily reacts with atmospheric oxygen, forming a protective layer of aluminium oxide, which prevents further reaction. That is why when you pour water on a cooking pot made of aluminium, there is no reaction. It's because of that coating of aluminium oxide. Zinc reacts when heated in air. It forms zinc oxide. Same, lead reacts when it is heated, reacts with oxygen to form lead oxide or lead 2 oxide. Copper similarly burns in oxygen, or when it is heated in air, it forms copper 2 oxide. So here you can take note of the color changes. These two metals are gray, but when they are heated in oxygen, their color changes. So this is gray metal. When it is heated in oxygen, it forms a solid which is yellow with hot, white, when it is cold. Sometimes in the theoretical paper you are given a description of a solid which is yellow when hot, white when cold. They know that the solid that is being described is zinc oxide. And then lead 2 oxide also exhibits 2 colors depending on the temperature. So the metal itself is gray, but when heated in oxygen, when it is hot, it is orange. It is orange when hot, and then on cooling it becomes yellow. Yellow when cold. So also when given a description of a solid which is orange when hot but yellow on cooling, then that will be description of lead oxide or lead 2 oxide. Then copper is brown metal or red brown. When it burns in oxygen, it forms a black solid. So it is important to note the color changes of the substances, because sometimes they act as a clue. In theoretical papers, you are given descriptions of substances and you are required to identify what that substance is. So knowing the color changes becomes very important. It will really help out. Now, I want to give some special attention to the following 2 metals. 2 metals are very special when it comes to reacting with air. And the first metal that I want to give attention to is sodium. Now, we know that air, the most active part of air is oxygen. Apart from oxygen, there is nitrogen, which is by volume occupies the largest percentage. About 78% of air by volume is nitrogen. Then we have other components like the noble gases and carbon dioxide, which they are unreactive. Nitrogen is generally unreactive. So when you burn these metals in air, nitrogen does not react with them. And the reason why nitrogen is unreactive is because of the nitrogen triple covalent bond, this one, which binds into N2 molecule. So this bond, the heat produced is not sufficient to break this bond to make these metals to react with nitrogen. But with oxygen, this is very active. It is the active part of air. So the metals easily react with oxygen because it is active. Now when it comes to sodium, sodium is very reactive. It will react with oxygen without any heating, but when heated, it will react with nitrogen as formed to form sodium nitride. But without heating, sodium reacts with oxygen, and here in limited or just air, ordinary air, with air to form sodium oxide. But so here in air, just ordinary air. So in air we have limited supply of oxygen, but when you have air enriched with oxygen, sodium forms another oxide which we call a peroxide. So when you have plenty of oxygen, let me put it as air enriched with oxygen, then instead of forming sodium oxide, sodium peroxide is formed. So sodium forms 2 oxides when it is when it reacts with oxygen. So in air, normally it forms sodium oxide, But when the air is enriched with oxygen, it forms sodium peroxide. So this is what we call sodium peroxide. And then when it is heated in air, when sodium is heated in air, it forms sodium oxide, and also sodium will react with the nitrogen in air to form sodium nitride. Sodium nitride. So sodium therefore becomes a much special metal compared to the rest. Now we have another very special metal, and this other metal is iron. So as you have seen these other metals, just metal plus oxygen, you get a metal oxide. So like this is aluminium oxide, zinc oxide, lead 2 oxide, copper 2 oxide. Iron, when it reacts with oxygen, or when you burn iron in oxygen, now iron has 2 oxidation numbers. We have iron 2 and we have iron 3. So neither of this is formed. Iron 2 nor iron 3 is not formed. Instead, a different oxide is formed. Now this is what we call triion tetraoxide. Triion tetraoxide. This is formed, which previously we saw it was one of one of the ores of iron, which has this formula, and that is magnetite, which has this formula. So take note, when iron reacts or it is heated in oxygen or in air, it does not form iron 2 oxide, it does not form iron 3 oxide, but instead it forms triion tetraoxide. So let's consider the next property, that is reaction of metals with water and steam. Now, in discussion of this, I want to join these two, water, steam, and dilute acids, and I want to simplify this one using the reactivity series as follows. So, in brief, I've summarized here the reactions of metals with water, steam, and dilute acids. In the order of reactivity series, when you look at them this way, it really helps, because there's a common question that usually comes. You are given elements in which the letters do not represent the actual symbols of the element. Then with description, some of them react with water, others they don't. Some react with steam, others they don't. Some react with dilute acid, others don't. Some take away oxygen from others. Then you are asked to arrange these metals in the order of reactivity series. In this case, knowing how these elements react, or they are in the reactivity series, and how they react with water, steam, and dilute acids, it can be very helpful in answering such a question. So let's start with water. Now, the metals high up in the reactivity series, from potassium, let's say, to calcium, they react with water, forming an alkaline solution and hydrogen gas. So if it is potassium, you get potassium hydroxide. Hydrogen gas, you use sodium, you get sodium hydroxide. You use calcium, you get calcium hydroxide. Now magnesium, almost there is no reaction. When you put magnesium ribbon, for example, in water, there will be bubbles of a gas that will form on the magnesium ribbon. That gas cannot be collected because when those bubbles are not released. So the reaction is very, very slow, almost no reaction. But since there is presence of bubbles on the magnesium ribbon, then it will be incorrect to say that no reaction. Yet there are bubbles, so there is a reaction, but it is very, very slow. Then from aluminium downwards, this metal, they don't react with water, cold water in that case. So the water we are talking about, this is cold water. From aluminium downwards, no reaction with cold water. Then with steam, these metals that react with cold water, they react explosively with steam, they react explosively with dilute acids. Hence, if you are carrying out an experiment, this should not be tried. Don't react these three metals, potassium, sodium, calcium, with steam. Don't react them with dilute acids because their reactions are very, very explosive. Now, as we move down the reactivity series, there is decrease in reaction. Now, magnesium will react vigorously with steam. Aluminium, so as you move down, the rate of reaction decreases. Aluminium, zinc, and iron, they will react moderately as you move down with steam, forming metal oxide and hydrogen gas. And here I also want you to take special notice of this metal ion. So we saw that when iron reacts with oxygen or burns in oxygen, it does not form iron 2 oxide, it does not form iron 3 oxide. Instead, it forms the triion tetraoxide, this oxide, which is also formed when iron reacts with steam. It does not form iron 2 oxide, it does not form iron 3 oxide. Instead, it forms triion tetraoxide. So 3 iron, 4 oxide. Tri is for 3, tetra means 4. So 3 iron atoms, 4 oxygen ions. So the compound we call triion tetraoxide. But from there, from iron downwards, those metals, they don't react with steam going downwards. With acids, as I've pointed out, these three react explosively. Then magnesium, aluminium, and zinc, they react moderately, forming salt and hydrogen gas, which are given an example of an equation here. Zinc plus dilute hydrochloric acid, you get zinc chloride and hydrogen gas. And this is how you prepare hydrogen gas in the lab. Also, you can use calcium because it reacts moderately with cold water and collect some hydrogen gas from that reaction. And then reaction of dilute acid with iron and lead is slow. With lead, for some of the acids, particularly the sulfuric and nitric acid, the reaction starts and stops due to the formation of insoluble sulfates and chlorides, respectively, of lead. Then from copper downwards, because hydrogen does not react with water because it cannot displace itself from water, then copper, no reaction. So you notice copper does not react with dilute acid, it does not react with steam, it does not react with cold water for one simple reason. Dilute acids contain hydrogen ions. Their reactions involve displacement of hydrogen. Water, whether steam or water, it contains hydrogen. This reaction, you can see hydrogen is liberated. Even where there is a reaction, hydrogen gas is liberated. Copper being below hydrogen in the reactivity series, it cannot displace hydrogen in water, neither in dilute acids. That is why copper does not react with dilute acids, and as well, copper does not react with steam as well as water because it is below hydrogen in the reactivity series. Hence, it cannot displace hydrogen from those reactivity series. So I will run just notes for those who might want to copy on reaction with oxygen, dilute acid, and then that will be the end of this lesson. Then lesson 8, we will continue with the two remaining properties, that's reaction of metals with chlorine, then reaction of metals with concentrated sulfuric acid and nitric acid, and then we look at the uses of metals, and then that will be our conclusion. So these are the notes for the chemical properties, metals reacting with air, so you can pause and copy those ones. And here are now the notes for the reaction of metals with water as well as with steam, and the equations thereof for the reactions. Okay, so that will cover up to where we have discussed reaction of metals with air, with water, steam, and dilute acids. Up to with the reaction with dilute acids, which I've just summarized there on the board. So next we look at the reaction of metals with chlorine, then with concentrated sulfuric acid and nitric acid. Thank you for watching. For those who are accessing through YouTube and have not subscribed, please subscribe to see the other lessons that I have done for the Form 4s. Thank you and God bless you.